Hello everyone. Today I am coming with new chapter Electromagnetic Induction. After magnetism, your next chapter is Electromagnetic Induction. In short, you can say EMI, Electromagnetic Induction. Okay, electromagnetic induction means is a phenomena by which can produce the induced EMF and hence induced current due to the change in magnetic flux linked with the coil. So, electromagnetic induction is the phenomena by which we can produce induced EMF, hence induced current by changing the magnetic flux linked with the coil. So, student, next question is what is called magnetic flux? Magnetic flux denoted by phi b is equal to, we can write B dot A. So flux is a scalar quantity, dot product of magnetic field and area, B dot A. Suppose you have taken a coil A whose area A in the direction, the normal to the area, and there is a lines passing like this. So the magnetic field, these are the magnetic field lines, okay. Angle B with A is theta. So we can consider those lines which are in the direction of the area. Means in this direction we will get B cos theta. Okay. So we can write phi B is equal to B cos of theta into A, or B A cos theta, or we can write B dot A. That's why phi B means B dot A. It's a scalar quantity, B vector, area vector. So student, what is called flux? The number of lines passing through that area, normally is called magnetic flux. The number of lines, total number of lines passing through that area, is called magnetic flux. And because of magnetic flux, here we have written B. If it's electric flux, then we can write phi E, means same electric field into area, but here we consider the phi B. And you know the unit of phi B, SI unit, B here Tesla, area means meter square, so Tesla meter square, in one word we can write Weber. So this is the unit of flux, phi B. So you can also calculate dimension of phi B. So when the phi B will be maximum, flux will be max. When theta equal to 0, cos 0 1, so we can write B into A. And when phi will be minimum, phi B minimum when theta equal to 90. If the direction of B is like this and area, then 90 means cos 90 0, so minimum will be 0. So this is all about magnetic flux. Students, next we have Faraday's laws. Here we have two laws. Number one, the quantity means the reason of induced EMF. Why EMF is induced in the coil? So from the first law tells us about the reason of induced EMF. Okay, whenever phi B changes, means whenever flux changes linked with the coil, then an EMF is induced and it lasts so long as the change in magnetic flux continues in the coil, and induced EMF lasts so long as the delta phi continues. So delta phi, continuation of delta phi causes the production of induced EMF. Understood? So this is the first law of Faraday. And the second law tells us about the magnitude of EMF. So we can write the induced EMF E is directly proportional to the rate of change of magnetic flux. Say with me, students. Induced EMF is directly proportional to the rate of change of magnetic flux. Rate of change of magnetic flux. Rate of means by T. Change of means delta phi. So delta phi by delta T. So it is constant which is 1. So we can write, if K equal to 1 constant, then we can write E equal to number of turns. Okay, we can consider number of turns in number of turns, because we considering here coil. Coil means there should be number of turns, so there in number of turns. So N d phi by dt. Here we take constant K equal to 1 because we considering here medium is here. So E equal to N d phi dt. D phi means, say with me, d phi means change of flux. Dt means time. So d phi by dt will be the EMF, induced EMF. Okay. N is the number of turn. So this is the magnitude of induced EMF. Now students, third law of EMF. We can consider this is the third law of EMF. That means Lenz's law. Lenz's law. Lenz's law. So Lenz's law, in Lenz's law, just we can write E is equal to minus N d phi by dt. Means the induced EMF, this induced EMF always oppose the cause which produces it. The induced EMF always opposes the cause which produces it. So d phi dt, the change of flux, actually produce the EMF, and the negative sign represents it always oppose the cause which produce it. Okay. So this is the Lenz's law, same as Faraday law, only puts negative sign in front of this. Okay. Now Lenz's law tells about E equal to minus N d phi dt. Negative sign represents the it always opposes the cause which produces it. So in this case, Lenz's law, from this Lenz's law, we know about the polarity of induced EMF. Okay. So students think Faraday's second law tells us about the magnitude of EMF, but Lenz's law tells us about the polarity of induced EMF. So the polarity of induced EMF is such that, so we can say Lenz's law, polarity of induced EMF or current is such that it always opposes the cause which produces it. Now think, from this Lenz's law, students, we can explain the laws of conservation of energy. Here, mechanical energy, yes students, mechanical energy actually converted into electrical energy. Think, suppose there is a bar magnet N and S near to the coil. Then what happened? Then in front of the coil, the direction of current should be anti-clockwise, so that in front of the coil that produce a north pole, and north repel each other. So against the repulsion we have to put some energy or work done so that it could come closer to the coil. Okay, so that's why work should be provided, mechanical energy should be provided. Okay, next, if the bar magnet go away from the coil, then what happened? If it go in this direction, then what happened? Then here south pole is produced. South pole means clockwise. This is anti-clockwise. This is clockwise direction. So in that case, north and south attract each other. So against attraction, we have to provide some mechanical energy to go out from the coil. So that's why every time mechanical energy given to the system to get the current. So here mechanical energy converted into electrical energy, and that would be explained by the Lenz's law. So Lenz's law means, see here north pole and north pole oppose each other. So the cause of production of EMF is to you have to you should provide some relative motion with the bar magnet and coil, and this relative motion it always opposes by the force of attraction or repulsion. So Lenz's law tells about the first thing, it tells about the polarity, and by the Lenz's law we can explain the conservation of energy. Students, in next video we learn to produce motional EMF, okay, and the power consumption, it is current, lots more, okay. So for today, that's all for today, okay. Thank you, students.